Okay, so anybody who has a Toshiba TV and it starts flickering like this, I'm going to try to attempt to repair this. This was a freebie, and it's a 46-inch, I believe, and it's an LED LCD TV. Now I just have the little camera going just for a video signal because these TVs, what they do is, it just went out. And you can see the TV is actually still on. If you shine a flashlight on the display, you can still see that the display is working. Now, what's probably causing this is either the main control board or the LED driver itself. And a lot of times on TVs, what will fail on these is the capacitors in the power supply. However, the power supply, the main rail that powers the backlight drivers and some of the other electronics is a 24 volt power out, and you can see the voltage is stable. Even when it flickers, the voltage is stable. Now these TVs, newer TVs are probably much less boards, and you can see my one test lead fell off, but you have your main control board, your power supply board, and then under this cover is the LED driver. And that's where I think the problem is. However, I have read, looking up some stuff on these TVs, that it could be the control board that's failing. Because what these TVs do for Energy Star compliance is if there's no video signal or it's just a blank screen, it shuts the backlight off. And I'm just going to pull my test leads out, hopefully without shorting it out because it's still plugged in. Now, I don't recommend anybody doing this unless they know a thing or two about electronics, because on this board, and at least in the United States, there's 120 volts running through the primary side, which is this whole side right here. You can see the AC power input, and then the low voltage side and the secondary side is right here. Now, what lines I'm going to try to play around with are, I'm going to try to hold this and not zap myself, are right here. There is, and what's really nice about this TV is you look right here on the power supply and everything's labeled. What I'm going to play with are these two lines right now to start troubleshooting. And basically what these are is the backlight on control, which is where one problem could be. And the second one is this one, which is the dimmer circuit. And basically what that does is it allows you to go into the menu and control the brightness of the backlight from your remote control. Another thing that could be causing an issue is I have this cover on it because this LED driver on this particular TV outputs 100 volts through these wires right here. And this is what goes to the backlight on the TV. This is an edge-lit LED LCD TV. So basically what these lines do is there's four positive, or it could be negative. I haven't really tested it yet, but there's 4 or 5 wires. These 4 wires, the white ones, are what the output voltage is, and these go to 4 LED strips that are basically run along the top of the display. And then this one is a central ground that all the LED strips go to. Now this particular board, I don't know yet if it controls the positive or the negative voltage, but at full brightness this will output 100 volts. So basically it takes a 24 volts from the primary power supply and the controls, or the control signals, through this cable here. And you can see this TV, this power supply is using multiple, either multiple brands or multiple sizes, because this is where a second LED board can plug into. And it runs along here and goes into here. And then this, because this is a 3D capable TV, this line gets hooked into the display controller down here to sync the backlight with a pair of LED goggles, or LED 3D goggles, and other stuff. So that line, don't think is causing a problem, because all this does is it's just control signals. But there's another thing that could be failing in this, and basically I'll show you on this board because, well, first I'm going to unplug it while I'm like poking around in here. Alright, now that it's unplugged and laying flat, I can show you guys a little bit better. Basically, you have the main control board, which controls the power supply, the display driver, and the LED driver. What could possibly be failing in the LED driver, and I've seen this before on these type of TVs, and because this has a cover on it, I'm going to show you on here. These devices right here are called capacitors, and what they do is they store power, kind of like, or electrical charge, kind of like a battery, and they smooth out the power from the power supply. What happens though is when these get hot, they degrade, and when they degrade, they start to draw more power and eventually turn into a dead short, which then will trip protective devices in the power supply, so nothing catches on fire and nothing blows up. So I'm going to take the cover off of this now, and I'll see. I'm pretty sure there's a capacitor under there, because this is a step-up power supply, or a boost converter, that takes a 24 volts coming from the power supply and boosts it up to 100 volts, which is what comes out of here to drive the edge-lit LED strips. Alright, so now I have the cover off of that board, and I powered the TV back on, and you can see that's what the board looks like. And this is, again, the LED driver board. But you can see that this is what the backlight's doing. Now, on this board, yep, it just went out. So, I'm going to unplug the TV and just let it sit for a minute so the capacitors discharge. But basically, you can feel components and nothing is getting hot. So I don't think it's a problem with this board. And I put a voltmeter on the capacitor, and this big one right here, and basically the same thing. No voltage drop, and it's not drawing enough power to cause the circuit board to cut out. So I'm thinking that there's a problem with this board, and it's not able to output enough voltage for the driver board to function correctly. So what I'm gonna do, and this little trick will basically make the backlight stay on, or also it'll make it go to full. I don't know if it'll make it to go to full power, but basically what I'm gonna do is I'm gonna jumper these wires together, where you can see right here, these two wires is BL on, which stands for backlight on, and then dim. Now, the dim one is working fine. What I think the problem is the backlight on circuit. So what I'm going to do is I'm just going to make a little tiny wire, and I'm going to jump these two together, and they are 3.3 volt logic signals. So if there's no power being drawn from this, so jumpering them together will not hurt anything on the control board, nor will it hurt anything on the power supply. So I'm going to just give that a shot and see what happens. Alright, so now I have the cover off of that board, and I powered the TV back on, and you can see that's what the board looks like. And this is, again, the LED driver board. But you can see that this is what the backlight's doing. Now, on this board, yep, it just went out. So I'm going to unplug the TV and just let it sit for a minute so the capacitors discharge. But basically, you can feel components and nothing is getting hot. So I don't think it's a problem with this board. And I put a voltmeter on the capacitor, and this big one right here, and basically the same thing. No voltage drop, and it's not drawing enough power to cause the circuit board to cut out. So I'm thinking that there's a problem with this board, and it's not able to output enough voltage for the driver board to function correctly. So what I'm gonna do, and this little trick will basically make the backlight stay on, or also it'll make it go to full. I don't know if it'll make it to go to full power, but basically what I'm going to do is I'm going to jumper these wires together, where you can see right here. These two wires is BL on, which stands for backlight on, and then dim. Now, the dim one is working fine. What I think the problem is the backlight on circuit. So what I'm going to do is I'm just going to make a little tiny wire, and I'm going to jump these two together, and they are 3.3 volt logic signals. So if there's no power being drawn from this, so jumpering them together will not hurt anything on the control board, nor will it hurt anything on the power supply. So I'm going to just give that a shot and see what happens. Alright, so now I have that jumper wire in place, and I did it actually on the control board side because it was just easier to shove the pins in, and apparently that does not work. So I think what that means is that this whole board is either going bad or there's something in the actual display that's failing. On this board you can see these things are called MOSFETs, and basically what they do is they switch the voltages on and off, and they actually, the way this is set up is it goes through this transformer to boost the voltage up, and then it gets turned back into DC voltage to go to the drivers. What I think is a couple of these MOSFETs may be failing, and they just can't keep up with the demand on the or that the LEDs are putting on it. Because on this TV, when I turn the backlight down under 30%, it functions perfectly normal. So I think that this is definitely where the problem is this board. I found online I could probably order one for 30 bucks or so, and then this TV should be good as new. So here's an example of an older TV that had the capacitor problem that I was talking about. This is a 36-inch Philips that was made in 2006, so it's an earlier generation flat screen TV, and as I said, or as I mentioned before, everything is a different board. You got your backlight driver board, and in this case this uses cold cathode fluorescent tubes instead of LEDs. You got your primary power supply. Under this cover is the main control board, and then you have a board here that has your some inputs and outputs, and this TV actually has USB, which is kind of neat. You can play like MP3s and stuff like that. You have this board in the front here that is for the little LED that comes on, and also the infrared receiver, and then you have the other board here that has the buttons on the side. Now this TV, there was actually multiple failures on this, and I was able to replace and repair some of the parts. On this board, what happened is one of these capacitors failed. It's actually not one of these. It's under the cover. Basically, one of these failed and was shorting out, and it was tripping out the power supply, and it was causing the LED to flash an error code. And when you look it up, it was a power supply problem or an overload. And the other problem was on the power supply itself. When I got this board working again, and I replaced the capacitor, and I think there was a fuse that blew too under here. It would hang up. The picture would freeze, and like the remote, weird things like remote would stop working, the buttons wouldn't work. It would just turn off and then basically flash and stuff like that. So what I did was on the secondary side of the power supply, there were several problems. These two diodes weren't working correctly. They were basically just worn out, and they weren't letting the proper amount of voltage go through. And these, the way they're set up, is set up as a bridge rectifier for the secondary side, which is right here. And the other problem was, which probably or most likely led to the failure of the diodes, was some of these capacitors actually were bulged. So like this top part right here, it was actually bulging out, and the capacitors were basically shorting out, getting hot, and drawing too much power, and again tripping the protection in the power supply, which basically made these diodes overload and just basically fail. So this TV works 100% now, and yeah, it's an older TV, but you know, it's good to have for a spare, and especially if you want to be outside or something and you want a TV that you really don't care about. So yeah, that's basically how you troubleshoot and repair a modern television. Is you just basically check your voltages. That's like the number one area where you want to start, is your power supply. Is, are your voltages fluctuating, and even if, are they outputting the correct voltages? Now on this TV, you can tell because it's a little bit older, it does not have any of the pinouts and the explanations of stuff like the newer TV had. So basically what you just have to do is you have to look up online for the repair manual or the service manual for these things, and you'll be able to figure out what voltages go where and what they should be. Like this TV, because it's older, it has a 3.3 volt rail for powering the logic chips in on the control board. It has a 5 volt rail for I would imagine, again, for the logic chips, the 3.3 volts, probably for like the main processor and stuff like that, and the 5 volts probably for some of the other controllers. It has a 12 volt rail for powering the audio amplifiers for the speaker, or the audio amplifier for the speakers. And actually, you know what, thinking about it, the 3.3 volt power is actually on all the time, and the 5, 12, and 24 volt rails are turned off most of the time. So my best guess is the 3.3 volt rail is for the standby current that runs. So if it receives a signal from the LED, or you push a button on the side panel, it basically can wake everything up. And then it has what comes out here is the 24 volt power for the backlight inverter. And again, this TV is CCFL, which is cold cathode fluorescent. It's an older technology, but it's proven to be very reliable. The only downside is when you get rid of a TV like this, the CCFL tubes have mercury in them. So a lot of places you can't just throw a TV like this in the garbage. And you can see on this board it has 6 tubes in it, and basically the tubes, they look like fluorescent light bulbs, and they just basically run across the back of the screen, and then there's a diffuser and stuff like that. The edge-lit TVs that we have nowadays give you much better picture, and they don't fade over time. Like this TV, the picture is has a little bit of a yellow tint to it because it was used as a digital signage display, and it has a lot of hours on it. The LED edge-lit displays, and even like the ones with the direct backlight and OLED displays, they basically do not change color. They'll just get dimmer over time. But however, with the OLED displays, you have to be careful with leaving static images on them, because they're subject to something called burn-in, where you get like a static image. But that's pretty rare. The technology has come quite a long way these days, so you really don't have to worry about that. But the OLED displays, they will not have an LED driver board or a inverter board like this, because OLED displays generate their own light. The light source is actually built into the display, whereas these types of displays and the edge lit displays have layers. So you have your LCD panel, which has the pixels in it and the different colors and stuff like that, and then behind that there's different layers like a diffuser and stuff like that, and then you actually have your backlight. And now that this TV is working, I'm not going to take the actual display apart, but if you were to take the metal panel off of the display, you'll be able to see the very, very, very tiny fluorescent tubes. They are also much less efficient than the LEDs that we have today, which is why if you go and get a laptop, none of the laptops have that. Remember the old laptops? They would get hot in like a certain spot on the screen. That's because they used an inverter board, much smaller than this, but basically it worked the exact same way. But that's actually one of the reasons why these early LCD TVs were prone to failure, is because this board generates a lot of heat, because it's basically stepping up the 24 volts that comes from the power supply up to several hundred volts to run the fluorescent tubes in the backlight. And actually, that's actually one of the reasons why I'm pretty sure that Toshiba TV that I'm working on, that board failed, was because it got hot. When I get the new board, what I'm going to probably end up doing is on the MOSFETs, I'm going to put a heat sink on it. So because I have a feeling that because that TV was also used as a digital, what do you call it? A digital signage display, so it ran and ran and ran and ran and ran, is those MOSFETs got hot and they just wore out, and now they're unable to output the required voltage, and it's basically tricking the power supply into thinking there's an overload and it's shutting off to protect itself. So I think I'm going to put heat sinks on the MOSFETs for that, and that's, like, again, very easy to do. And even though, yeah, it's an old TV and TVs are so cheap now, I don't know, it's kind of neat to see how these things work and how the technology has progressed. I mean, you can even see it right here. You look at this layout of this TV compared to the other one, and that's just about a 6-year difference. A lot of the newer TVs now, they're making them so thin that the power supply is completely separate. It's a brick that goes somewhere else, and then the television, the inside, the guts of the TV, especially some of the ones with the curved screens that like Samsung is making, the control board has everything on it. So it has the logic chips, the main processor, and the display driver on one circuit board, which kind of stinks because it makes fixing them a heck of a lot harder. But then again, that's kind of the way they're going. And I'll give you an example of improving technology. That TV is a 4K LG. I picked it up for about $600, and it's a smart TV and does everything. This TV, not a smart TV, but it still works. And now that it's up and running, I got a nice, pretty decent spare TV. So hopefully you guys learned something from this. And again, if you're not experienced with electronics, do not take the back of your TV off, because these hurt. And even having it unplugged for like a minute, just wait like at least 10 minutes after you unplug one of these and start working on it, because these capacitors, like I said before, they act as like little batteries, and they actually hold on to their charge for quite a while. On the Toshiba TV, when I had the voltmeter hooked up to the 24 volt rail, even after the TV was off for a good 5 minutes, it was still reading like 10 or 12 volts. So that's like a good like safety tip too. And the other thing is too, is if you're salvaging components from stuff like this, make sure that the power supply is completely dead. And to do that, you basically take a screwdriver, and I know that this one doesn't have any power in it left, but you basically just go like this. You just short out the terminals on these capacitors, and you might get a little bit of a spark. It's okay. But basically what that does is it discharges any power that's left in these, so you can safely work on it. On a board like this, it's a little hard to do because these capacitors are soldered to the board, and you have to unscrew it to basically get to the bottom. When you unscrew these to discharge the capacitors and to salvage them for parts, be very, very careful not to touch anything, otherwise you can get a really nasty shock. And yeah, but other than that, for the most part, fixing these LCD TVs is pretty simple and straightforward. And yeah, so that's pretty much it for today.